title of this video is Author Competition. Authors compete in all fields. Popular fiction, science fiction, they also compete in academic engineering writing. And why shouldn't they? Those authors who are better than other authors should be recognised for their contributions. And authors who have a one-off lucky contribution for something that isn't that significant but just happens to be used by a lot of people, that isn't that sophisticated, well, maybe they shouldn't be as recognised as somebody who contributes consistently. Author competition is important. What I'm going to talk about is something called the Hirsch Index. Now, there are many metrics for measuring authors, but the H Index has been around for quite a while, and it's certainly worth knowing about. And I'm going to get you to focus on H Index for this course. So let's talk about what it is, where it came from, and some of its advantages and disadvantages. The H Index was suggested in 2005 by a physicist from University of California, San Diego, whose name was George Hirsch, which is why it's called the Hirsch Index or the H Index. And it was a tool for figuring out the relative quality of somebody's writing. So if you look at the citation count on the left for this particular graph, you'll see that one paper is off the chart. Somebody got a publication in and it's been cited potentially hundreds, potentially thousands of times. But then if you look at the majority of the work, you can see that it isn't cited so much. So this index was suggested to try and get a sense of the consistency of the contribution, not of some lucky kind of citation. That was the motivation behind it. Incidentally, it's also called the Hirsch number or the H number, H Index. So we're going to look at how we calculate the H Index, how we figure it out, what it means, and what the implications of it are. Now, the H Index does not reflect the average citations per document. So you don't simply say, I published 20 papers, in total they've got 200 citations, my H Index is 10. That's not how it works. And if you think that's how it works, it doesn't work like that. It's slightly more complicated, but not much. Let's look at how it works. Well, you actually have to look for H amidst the publications. So say we've got this particular scientist or an engineer, they've got a number of articles. The column on the left is the number of times their article has been cited that many times. So if you start at the bottom, they've got 12 articles that have 1 citation, 11 articles with 4 citations. Scooting up to the top, they've got 2 articles with 70 citations and 1 article with 87 citations. So they've got quite a reasonable publication record. There's probably 100 articles they've published, and this is the distribution of the number of times their work has been referenced. Referencing matters, and this is why. So how do we find H within this? Well, a simple way to do it is to start from one end or the other end. Let's start at the bottom. 12 have 1, 11 have 4, 10 have 6, 9 have 8, and it's at that point that it swaps over. So 8 articles have been cited at least 8 or more times, and the remaining articles have been cited 8 or less. So that's the magical point. So this particular author would have an H Index of 8. So the initial idea from Hirsch was to discriminate the investigators who persistently produce high quality work from those who experience a lucky break in their career. Let's talk about a lucky break. The inventor of the RNA isolation method, Peter Chomsky, wrote a publication on this method and has a total of over 65,000 citations for that one article. This was published back in 1987. However, Peter's current H Index is 23. So that's a reasonably good H Index and quite strong in his field, but it gives you a sense that you can have one article that just absolutely goes off the chart, but your consistent contribution will come through in the H Index. And that was really why Hirsch invented it, because he just saw that there was a little bit of inconsistency in the way that the metrics were being used. Let's talk about who is the greatest in terms of citation of all time. Well, apparently there are 4,000 scholars back in 2020 with an H Index greater than 100. Also says Google Scholar Metrics. Let's have a look at the top 20. You'll see some names and you'll see some institutions in there that you probably recognise. Michel Foucault, a French author in sociology and philosophy, really stands head and shoulders above the rest in terms of citation, and his H Index is extremely high. You might see some other names that you recognise in there. Sigmund Freud, perhaps, from the University of Vienna. And those of you who are familiar with the Ivy Leagues in the United States will see lots of very prestigious institutions represented. It's definitely worth having a read of the writing of some of these authors, because if you want tips about how the best do it, there's no better place to start. I highly recommend dipping into these guys and taking the time to doing some reading. And you're required to do reading as part of professional development as an engineer, so it's worth reading the best you can find. Now, there are some issues with H-index. There was a study done in 2012 which showed that H-index is extremely field specific. If you look at computer science, it's down the bottom. If you look at clinical medicine, it's way up the top. Now, in some sense, that says something about the amount of work happening in the relative areas, the amount of things that are read, that are cited, that are published, but it doesn't allow you to really compare apples with apples. And where this creates an issue is when there's positions that are created in particular for cross-disciplinary fields. For example, if you're applying for a bioinformatics job and you have a background in computer science, you're not going to be able to compete with somebody with a background in immunology or biology or chemistry, simply because the citations in that field are so much higher. So it does create some issues, particularly when there are new cross-disciplinary fields. So the engineering H-index is different again. It's lower than computer science. It's off this chart, in fact. And that's not a problem. As engineers, we're within our field and we cite as much as we are within that field. But if you really want to go off the chart in terms of H-index, do some engineering with clinical medicine, get something published in a medical journal, and that way your H-index will soar. Now, there are some other issues with H-index. Let's get into some of those. Well, H-index is counted on articles, and articles aren't the only game in town. There are patents. There are patents worth millions and millions of dollars, which are way more valuable than papers. There's pieces of software which are used by many people in their field. There are really useful textbooks used to teach engineers at university that are really useful. If you represent something with one number, it creates issues. I can't stress how important that is. And I'm going to talk about how that's actually played out in some workforces. And you need to really keep that in mind, because a number is simple, but it always misses something. Other issues with H-index, some papers literally have thousands of authors. Some studies are huge, they go over decades, many people contribute to them, and the list of authors is just huge. How do you possibly, distribute the H-index between the authors? Do they all get a chunk of it? Who gets it? What's the contribution? What's the split? It's a difficult one that they currently don't have a solution for. There's also a correlation between age and H-index. If you publish something in the 1920s and it's reasonably highly cited in the 30s, well, it's likely to be continually cited. And so by the time you've got into the 2000s, you can have hundreds, thousands of citations. But if you publish something in the last 5 years, it's actually really difficult to collect that many citations, unless the work is absolutely astronomical. So there's a correlation. Other issues, again, with authors. Some people put their friends on as authors, people they want to work with, people they're honouring, people pay to get put on as authors. There's all kinds of interesting things going on in author lists, and I'm going to get into that in another video. Another issue is that you want a metric that kind of tells you something about the future based on the success of the past. And just because you have a really high H-index doesn't mean you're necessarily going to produce the next publication. Generally speaking, in engineering academia, it is accepted that 2 publications a year is the bare minimum. At Melbourne University, it's 4 publications a year. So if you're producing way past that, then that's all good, but that doesn't necessarily mean you're going to be contributing at that rate for the rest of your life. It may just have been some particular experiment, some design, some piece of work that happened to generate a lot of publications due to some characteristics, and that may come to an end. Altmetric is a good site to have a look at. It's got a list of other metrics for authors, and it can tell you some of the things related to patent software, etc. Definitely worth a look.